So in this video, we are going to look at second order partial derivatives. So just as we found second derivatives and derivatives of higher order in one variable, we can form second partial derivatives and derivatives of higher order of a function f of xy of two variables. Now, when we think about this, since my partial with respect to y, and you can add the partial with respect to x, are both functions of x and y, we can differentiate each of these with respect to x or with respect to y. And so as a result, there are four partial second derivatives. So we have f of xx, so this is taking the derivative with respect to x twice. F of yy, which is taking the derivative with respect to y twice. And then we have f of xy and f of yx. So this one is taking the derivative with x first and then y. And this one is taking the derivative with respect to y first and then x. So for our partial derivative, the first one we can do is with respect to x. So we could differentiate two times with respect to x. So there's different notations. When we're doing that, what we're doing is we have our partial with respect to x and we're taking the derivative again with respect to x. And so that leaves us the one notation is we put like the delta squared f over delta x squared. So this notation represents taking the second derivative of our partial and we're taking it with respect to x both times. The notation we mostly will use is this, f of xx. And so this is saying we're taking it with respect to x and then with respect to x again. So that's the partial derivative of f of x with respect to x. So this question asks us to find f of xx of this function. And so again, the first thing we do is we take the partial with respect to x. And then for the second order partial derivative, we're just going to take the derivative of this again, and in this case, with respect to x. So remember, y is my constant and x is my variable. So we have 2x squared. The derivative of that is 4x. And then we leave the y since that's like a constant multiplied by it. 3y squared has no x, so the derivative is 0. It's a constant. Minus 2xy, so the derivative of negative 2x is minus 2. And then we need to leave the y. 5y is considered a constant in this case, so it's 0. X squared is 2x. And then minus 7 is plus 0. And so my first derivative with respect to x is 4xy minus 2y plus 2x. So then this function, we can take the second derivative. Again, we could take it with respect to x or with respect to y. So when it says f of xx, that means that we're taking it a second time with respect to x. So the derivative of 4xy would be 4, and we leave the y. Minus 2y, well, that's a constant, so we have 0, and then 2x is 2. So I forgot the extra x. F of xx is equal to 4y plus 2. And so this is the second derivative with respect to x both times. Okay, and it's called a second order partial derivative. So then we can do the same thing with respect to y. So we can differentiate two times with respect to y. So we have df dy or delta f delta y. That's my initial partial with respect to y. And then we take that again with respect to y. And it's either this notation, or again, we'll use this notation more, f of y. And that's the partial derivative f of y with respect to y. So again, when we're doing this problem and we're finding f of y, we first take the partial of the original function with respect to y. So y is my variable, x is my constant. So we have this coefficient or this constant in front times the derivative of y, which is 1. 3y squared is 6y. 2xy is minus 2x times 1. Plus 5y, which would be 5. X squared is a constant and minus 7 is a constant. So we get 2x squared plus 6y minus 2x plus 5. And then we want to take the derivative again with respect to y. So we have f of y. 2x squared is a constant, so it's 0. 6y is 6, minus 2x is a constant, so 0, and so is 5. And so f of y is equal to 6. Now we have two more types, and they are called mixed partial derivatives because we're going to take one time with respect to x and one time with respect to y. And when we do mixed partial derivatives, we will do whatever order they specify. So in this case, they kind of write it in different ways. So if we have delta f over delta x, that means this is my first order partial derivative here. And then we're going to take the derivative of that again with respect to y. So we have delta dy, delta y, and that gives me this. Okay, and this notation is a little bit confusing because it goes from right to left. So whatever is here is what you do first, and then whatever is on the left is what you do second. And it's mostly because it comes from this notation that we're starting with the partial with respect to x, and then we're differentiating it with respect to y. Now, this notation here, f of xy, is the opposite. We read it from left to right. And so the x means we do that first, and then second, we do the partial with respect to y. So this means the partial derivative of fx with respect to y. So when you have f of xy, and again, this is the notation we're mostly going to use, you go left to right. So you start by finding f of x, so taking the partial with respect to x. So that gives me, we did this already, but this is 4xy, that's 0. This is minus 2y, that's 0, and then plus 2x, and then this is 0. And we did this one over here when we found that partial. But now we can take this instead with respect to y. So we have x and then we put y. So that's what we're doing second. And so now we're treating y as our variable and x as our constant. So the derivative of this would be 4x times 1. This would be minus 2, and then that would be 0. And so that gives us 4x minus 2. And that's my partial of x, y. Now we can do the other order. So again, we have a mixed partial. So for this one, this notation, we start with taking the partial with respect to y and then with respect to x. And that results in this notation. So again, it's a little confusing. We go right to left. So this would be what you do first, and this would be do second. But again, we're mostly going to use this notation, which is left to right. So the y is first and the x is second. And this is the partial derivative of f of y with respect to x. So when it's f of yx, we start by finding f of y. So we have 2x squared times 1 plus 6y minus, okay, this would be 2x plus 5 plus 0 plus 0. And that gives us the 2x squared plus 6y minus 2x plus 5. Okay, and again, we did this one for this, and you are going to get the same thing. But now instead of taking it with respect to y again, we're taking it with respect to x. So we're going to find the partial of y with respect to x. So x is my variable, y is my constant. So we get 4x plus 0 minus 2 plus 0. And f of yx equals 4x minus 2. So that would be my partial with doing y first and then x. Now, notice both of these, I get 4x minus 2, and I get 4x minus 2. So the good thing about this is that as long as our function is continuous, which is what we mostly will be dealing with in this class, that the mixed partials are the same. So it doesn't matter what order you do. If you do f of x, y, or f of yx, you get the same value. So you still should follow the order specified in the problem, but do know that all the cases that we are going to deal with, they are going to be equal. So if you have any questions, please let me know.